Hello everyone, good morning. I'm very happy to be here on this sunny morning to present my talk, which is titled Behave, Automated Testing of Data Pipelines Using BDD. And a little bit about myself. My name is Avneet and I live in Copenhagen and I work in a company called Nombre, which is a pharmaceutical company, as a data engineer. And we use BDD in our day-to-day work in combination with building data pipelines. All right, so let's get started. So first of all, I'd like to give you a little bit of background. Let's start with what are the different kinds of testing methodologies that are present in the software development processes. So we have behavior-driven development, we have test-driven development, and we have acceptance test-driven development. So for test-driven development, as you all might already be aware of, we write tests, and then we actually go on writing the functionality of the code. With behavior-driven development, the case is slightly different. Instead of writing tests, we actually define the features and the requirements in combination with the product owner, as well as a person from the quality side and the developers. So as contrasted to test-driven development, where only the developer is writing the tests himself, there can be chances of errors, and he or she might not be testing the entire thing thoroughly. But since behavior-driven development is a more user-centric approach, we start with defining these requirements and feature files as if the user itself was using the system or the functionality that is being put in the product that we are developing. And then we also have something called acceptance test-driven development, which is also derived from behavior-driven development. It's just that in acceptance-driven development, there's a very high focus on the acceptance criteria being met for these tests that we write. And we, as developers, can use a combination of these methodologies while defining tests for the code that we write. And a quick Google search shows you all the different kinds of testing frameworks that are available in Python. So we at Nombre use a combination of PyTest, unit testing, as well as Behave for writing the tests. So we write both kinds of tests for the data pipelines we develop, which is integration tests, testing the end-to-end pipeline scenario, which I'll show in a few slides. And we also write unit tests for testing smaller functionalities of the code. In this talk, we are going to take a little deep dive into behavior-driven development. So behavior-driven development, as I already mentioned before, captures the requirements of the product that you're designing. So the first step that you actually do is sit in combination with your developers, with your product owner, as well as a person from the quality side, defining the requirements and the features that we are about to code for. And once this is done, this is following the agile development process. This is then documented as user stories. And then these features are prioritized depending on what is most important to be implemented at that point. And then we sort of refine these features. Again, they go through a set of reviews by the quality people on the quality assurance side. And then we run these tests. We run these tests. Initially, they'll fail. And if they fail, then we write some code. And if they pass, then we verify, and this cycle sort of continues until we feel that the product, the features have been sufficiently developed for the product that we are going to release. And even once this iteration is complete, we often need to refactor, go back and refactor and release again if the user requirements at some point changes. So as I already mentioned before, the first step was based on capturing the user requirements from the people who we are building the product for, which is why it cannot be developed independently only by the developer. So once we have defined all of these features, and once this entire cycle has been implemented once, we keep on doing it for every subsequent release. So this is a short. This was a short intro to how the behavior-driven development cycle works. Now let's look at why or what are the advantages of a behavior-driven development approach over a test-driven development approach. So first of all, in test-driven development, we as developers are writing the functionality as well as the code. So it can be still error-prone, and it may not cover all of the edge cases and scenarios. In test-driven development, the focus is on building the thing right, whereas in behavior-driven development, very specifically, the focus is on building the right thing. And it is done in collaboration with the entire team. So still we use a combination of both these approaches while developing our products. So, and most of our code, with which most of our programming is done in Python when we code data pipelines. And so we use this framework called Behave. It's a Python library which is provided. And this is the main thing we use for writing our feature files, writing our scenarios, and also writing our step implementations, which I'll talk about again in a few slides. So on the right side, you can see an execution of a test that has been written with this in mind. So as I talked about, we sort of define the features before, and this feature is called showing off behave. And then in the scenario, we have running a simple test. And as you can see on the right, we have all of these feature files. And for each feature file, we have a subsequent Python file. And in that Python file, we define the functionality of the test that we are going to execute. So you can imagine the entire structure to look like that you have in your directory a folder called steps, in which you will have the features, which are the user requirements that you are defining along with your team. And then for each feature file, you will have a corresponding Python file. And in the feature file, the difference between these two files is that the feature file is written in the natural language text. It is in the Gherkin syntax. Whereas in the Python file, you're actually defining the implementations using given, when, and then statements. And this is what the output sort of looks like after you run the test. This will exactly show you how many features have passed, scenarios have passed or failed. And within each scenario, since you can have multiple steps, then it also gives you an exact output of how many steps have passed or failed. So one feature file can also consist of multiple scenarios. So in this particular example, we have one feature file and one scenario, but in the same feature file, we can also define multiple scenarios. And each scenario consists of a sequence of steps, which are called the given, when, and then steps. Now, this is the basics of how we sort of define our scenario. First, we sort of define what we are trying to do, and in the given step, we sort of define our prerequisites for running the test. So you can imagine each scenario as a piece of test in itself. In the given step, you define the prerequisites, and in the when step, you define what is expected to happen when you sort of execute the test. And finally, in the then statement, you are going to provide what is expected in the result. And it is the then step actually that defines whether the test will pass or fail, because it will verify the output with the things given in the then statement. So this is, and in the subsequent slides, we'll see what the step implementations also look like. So now that we've seen a little bit of what behave is, we are actually going to see how we actually write the behavior-driven development tests. And I will also show you an example of a data pipeline and where all we sort of write tests and what all things are we testing for. So in behavior-driven development, we follow the 3 amigos principle. That is, we try to look at how might we build a solution to solve a particular problem from the developer's point of view. From the business point of view, we are looking at what is the problem that we are trying to solve. And from the quality point of view, we are looking at what about this, what could possibly happen. This also includes both failure scenarios or scenarios where things could actually not go as they were expected to be. And since we are a pharmaceutical company, we go through a very strict regulatory and compliance and validation process for each and every pipeline that we develop. So that includes actually following all of these principles, and we have a quality assurance person and also a compliance and validation lead sitting on one end monitoring the entire process, monitoring the entire validation process. This is also very crucial because the data that we are dealing with is often GDPR data, and we sort of receive data for patients with diabetes, and they sort of have these continuous glucose monitors attached to their arms. And when this data goes into the digital health applications to which the continuous glucose monitor is linked, we sort of pull in that data from the application, and then we sort of build a pipeline on that data. The entire pipeline then goes through a compliance and validation process, which mainly involves behavior-driven development testing. This is because this is the language also that the compliance and validation people as well as the business owners can understand. If we talk about unit tests or any other kind of testing, it's often difficult for them to sort of visualize what is going on a very high level, and to visualize what is happening if we sort of show them just the code. Which is why we sort of write in a very simplified manner the natural language text, in natural language text, what is the requirement and what is that we are trying to do using the BDD feature files and scenarios. So then this is like the entire process. We illustrate what the problem is. Then we try to, in illustrating the problem, this includes like coming up with why are we actually trying to build that particular pipeline. So in the end, all of the data that we process gets loaded into our in-house data lake, and that data lake, all of the data that goes in has to be GXP validated. So that is the most crucial aspect, and BDD is actually very, very useful in that scenario to sort of communicate with our stakeholders as well as business owners as well as quality people. Then we sort of go and formulate all of these specifications which we get from the business owner as well as our stakeholders, and we try to come up with all of the features that we are trying to build. We try to then automate our acceptance tests using behavior-driven development, and then it goes through a validation cycle just to be GXP compliant, and then finally we provide it, once the coding is complete, we finally provide it to our users, who are the data scientists sitting at the end of who are consuming our data from the data lake, and then they sort of come up to us and give us feedback on what is it that they would like to see and what is a new feature request that they could possibly have in the data pipeline, and then we sort of follow the entire cycle again for every new feature that we try to add. And here are then, so now let's get into how or what are the requirements for writing the BDD tests. So in Behave, we write feature files. We have a directory called steps with the implementation of the scenarios, as I mentioned before, and all of these are in the Gherkin syntax, which is basically just natural language statements and specifications. And for each feature that we are writing, we can have either a scenario or a scenario outline. The difference between the two we'll explore in the coming slides. So this is basically all that you need to write BDD tests. So let's look at features. So now this is an example of a feature file. And as you can see, the first thing that we do is define the feature from a user's point of view. And we say, as a user who needs to access my allowance, I want to withdraw cash from my account so that I can buy some items. Then we define acceptance criteria. Now, these acceptance criteria also depend on whether you're writing acceptance test-driven development tests. Otherwise, you can also write all of the AND statement in each of the scenarios sort of means, the then statement sort of reflects the acceptance criteria. What I mean to say is that it is not necessary, but it's always a nice to have when you are writing a test to make it more descriptive, as descriptive as you can. So a feature file, as you can see, consists of these given, when, and then parts. So given, as I mentioned before, tells us exactly what are the prerequisites for the test or what is already available to us. And then in the when statement, we see what is going to happen when I do something. And in the then statement, we finally have the result. So these are two different kind of scenarios. And then statement basically gives us the outcomes. In the AND statement, that is like an additional thing that you can append to any of these statements if you have, for example, an additional prerequisite or an additional step that needs to be executed. Then a scenario, again following this, the earlier example. Each scenario, each feature file can have one or multiple scenarios. In this one, as we can see, there are 3 scenarios, and it can go up to endless scenarios, as many as you want. But it is always recommended that you break down your feature, break down your scenarios, and split it up across multiple feature files so as to be more granular about the kind of test that you're writing, and also isolate it from all the other tests. So the more feature files that you're writing, the more descriptive your requirements are, and the more you're able to communicate how many or how are you building the product to your business owners or stakeholders. In certain cases, we can also include a scenario outline. Now, that is the case when you sort of have examples that you want to give, as in for each of these cases that you have mentioned in the table, the entire scenario will run once, like for each example that you provide. And in the angular brackets, as you can see, we have provided the placeholders for what will go in. So, for example, in the first test, this entire thing will run with balance, with the values of balance as 100, withdraw as 31, receive as 0, and remaining is 100. And in the subsequent ones, it will follow suit with the following examples. This is when you have one test, but you want to run it multiple times for different examples or different cases. And you want it to pass or fail for each, or give some output for each of these tests. So this is how basically you would define a scenario outline. And your feature file can consist of both. And then each feature file that we have defined before, it sort of is associated with a corresponding Python file, and in that Python file, you sort of have your given, when, and then statements. So basically, in this particular example, which I took from the documentation, there are only two which are, statements which are given and then. And in the given, you're just saying that I search for a valid account. And then below that, given is a decorator, and below that you have your step implementation defined. So now, if you have, now in your feature file you'll have the scenario, and in your Python file you'll have these two, and it will sort of do a natural language matching for I search a valid account in this particular Python file, and then execute that one. And it is actually very, very sensitive, the thing that you write. So even a space here or there, or a dot here or there, makes a difference. And also, it's as far as I remember, it's not case insensitive. So so you have to be very careful, because it works on the matching principle. So each of these sort of then defines what is the functionality that is going behind when you're running the test. And that is actually all that you need to write the behavior-driven development tests. So feature files, scenarios, and then your given, when, then statements. And the name of the function that's defined here can be different too, based on your use case, and you can have, or based on your understanding. Context that is given as a function argument here is basically something that sort of goes on in all of these functions. So basically, context is, you can add things to the context, and you can sort of access these in other parts of your code as well. So it's sort of like a global. And then next, what I would like to show you is a typical example of a data pipeline. This is the one that we had recently built for, and it's called the Wegovy Care data pipeline. It was built for getting all of the data from the users of Wegovy into our data lake. And as you can see, we have an interaction between multiple accounts, multiple AWS accounts. In one of them, and this entire pipeline basically demonstrates a process where we are receiving the data in one AWS account, and finally we are sort of loading it into our data lake. And in between, there are several steps, and also an interplay between several accounts, because our partners, they sort of deliver us data into a specific account, which is sort of external and which is sort of public. However, we want to process the entire data and load it into our internal data lake, which is sort of inaccessible by the people who provide us data. And also, very restricted access is given only to the data scientists who are working with that data. So in this one, we actually have a replication bucket on one end, which is where the partner uploads the file, the data file, and then it gets copied into our AWS account and our AWS bucket. And then from there, we have an event rule setup, which sort of goes and delivers the, as soon as there's a bucket, a file drop in our S3 bucket, the file, there's an event triggered, and it sort of triggers the state machine that you can see on the other side. And that is basically a combination of 3 Lambda functions. And Lambda functions are nothing but like small functions that you can write to do some kind of processing. And they can be written in many languages in the AWS CDK. But we mostly use Python for all our Lambda functions. And this is where we also write our BDD tests. So, these are also what we test for. So, for example, the 3 Lambda functions that you see are the source Lambda, the raw Lambda, and the transient Lambda. So it basically indicates 3 functions which are sort of responsible for copying the data, processing it, and then finally putting it into our bucket where we want the data to be. And our feature files for our test scenarios for these, this entire data pipeline could be something as simple as check if the if the bucket is encrypted or not. So in that case, the step would be to actually go into the console and check the bucket, but however through the, it's not manual, it's through the API called Boto3 for AWS. So once we sort of design our pipeline, one thing that we do even before that is sort of define what are the things that we want to provide in the data pipeline that we are going to write these tests for. And these tests are the ones that I'm going to show you. So the first thing that we do, as I mentioned earlier, was defining our feature files, and some of the features that we want our data pipeline to have is, for example, an alarm notification, an availability and integrity feature, a bucket encryption feature, a bucket retention period, and pipeline run logs. So for example, in an alarm notification, we would like to have for the previous, if any of these Lambda functions or the event rule or anything fails, we would like a notification to be sent to the people who are monitoring. In our case, it's the digital health mailbox where it goes to. It's like a specific mailbox dedicated for monitoring all of the alarms and notifications, so we can sort of address it and do something about it. And then we have something called the availability and integrity feature. So in this one, what we want to do is basically be able to ensure that our data is available and maintains its integrity throughout the process of the pipeline. So this means that while it is going through all of these Lambda functions, we know that the content of the data that we are passing through these Lambda functions don't change at all, which means that the number of rows, number of columns, and the number of data types, not a number of data types, but the type of each of these entries that we have, they don't change at all. The pipeline is not modifying all of this data in any form, except for the transformations that we are implementing. So it could be as simple as removing nulls or enforcing data types or any specific data transformation requests that we get from our business owners or from our stakeholders. So it's basically what we are trying to check is that all of these transformations that we are doing are exactly what we expect it to be, and other than these transformations, there is no data modification in any of these way, any which way. Then we have something called the bucket encryption feature, which I was describing earlier, which was just that, like our bucket, which is sort of a placeholder for wherever we receive data, it is encrypted in all ways, and there's no chance of it being not encrypted, so that any kind of data that's there, we know that it's secure and has very restricted access to whoever we want it to be. Then we have bucket retention period. So in certain cases, we need to sort of retain the data for a certain amount of time and delete it afterwards. So we want a feature to check that after our that retention period has passed, the data sort of is deleted, and there's no data in our bucket. So this is another feature that we have designed. And finally, we have something called the pipeline run logs, which sort of are the run logs for the entire pipeline, and it sort of tells us about the monitoring of the pipeline. And once you have these feature files, you sort of give, there's a scenario that looks like this. And all you have to do is then write step implementations for the scenario, for this particular scenario. And in this scenario, we have the feature is, for example, is data is available to end users. And we have, as a data owner, I want to ensure that the data is available and integrity remains intact during the processing within the data pipeline. So this is what I was explaining before. And the scenario basically is that valid files will be available to the end users. How? That given an authorized user uploads a file to the entry point of the pipeline, when the pipeline executes, then the file will become available to the end users in our data lake, which is called Redshift. And then we have another scenario called no duplicates are found in Redshift. The same data is uploaded again. So this is how you can sort of design all of these scenarios. And the code, and the last step then is to just map all of these features, all of these scenarios to your step implementations. And they can be written depending on what functionality that you're trying to test. So yeah, finally we write our Python step implementation files and simply run behave main.py, and it will sort of execute and give us the results that we are expecting, which I showed in the very first slide, like how many features passed or how many failed or how many scenarios passed, etc. That is it from my side. And to conclude, today we saw Behave, what behavior-driven development is all about. We saw how to write feature files and scenarios and a little bit of description of all of those. We also saw like a little bit about a data pipeline. Yeah, that's pretty much it. Thank you.
Any questions?
Hi, thank you so much for giving some visibility to BDD. Okay, so I have a question for you. We use BDD in our company, and one of the biggest problems we have to deal with, because we have a lot of features files, is cleaning the database after each feature, because otherwise the features are not independent, or maybe even inside the feature, some scenarios are not independent and you can run it. I mean, you can't run them independently. So, I mean, do you have any insight that you could provide me to fix that?
So actually, there is something that you could do, and which we also do. There's like setting an environment for each of these features that you're running. So it's like, I can't exactly remember the keyword for it, but I think it's background. So it's like, but I'll need to check and then I'll get back to you on this. But it's like, before you begin a test, it sort of goes and cleans up everything. So those steps also you're defining yourself. So you can possibly implement something like that. So you have that functionality in Behave, and it's basically like a specific environment that you define for running a test. And this is not to be confused with Python environments, but it's just like you're sort of defining, okay, all of these things I need before this test runs. And this is contrasted with the given statement in the sense that like that environment sort of you can create for multiple tests. In that environment, you can sort of specify a test, specify a step saying that, from this database, go and delete all of the things that have already been executed.
Okay, thank you.
First of all, thank you for the talk. It was very nice. And my question will be, we use Jira or some Atlassian products for the feature like description, and our product managers like mostly work in that like environment. Is it possible to combine it with Behave, for example?
Okay, specifically about Jira, I'm not sure, but we use something called ADO, which is, I think it has a similar functionality. So in that, we have all of these like user stories, and I assume in Jira also there would be something like that. So for each user story, basically, we go and write all of these feature files. And we also write the acceptance criteria. And the acceptance criteria is that the BDD test should pass. So possibly could do something like that.
So you usually have like two places, like you need to have the feature files, but then you also write the like user stories and.
Yes, exactly.
Okay.
Yeah. So basically, all of this is sort of part of our code repository, and I think I could just show you a little bit what it looks like. Okay, so just while it's loading, it's basically that all of us, all our code is sort of stored in ADO, and that exists like an entire repository. Okay, and okay, it's here. Oh no, I think I just. And in that repository, you have all of the requirements and feature files and everything, but you also have user stories that sort of link to those feature files. So that's how we do it. And I think there's some trouble with my Wi-Fi, so I'm not like able to show you, but maybe we can, I can show it to you afterwards.
Yeah, I think I can imagine it now. Thank you.
Okay.
First of all, thank you for the call. Super inspiring. Continue with the previous question. I'm super curious about the maintenance part because in the previous question you had been touching the part that okay, this is super similar to the things that we have in Jira and so on. So first is in your team, in your strategy that you are using now, who is the one responsible to put in sync the feature files and all the stories and so on? And okay. The other thing is that you show us the one code that is very volatile because you touch some buttons here and there in the form. So it gets me thinking, okay, maybe you have some strategy for some feature files that are more volatile than other, for example, with the backend, something like that. Mm-hmm. So I don't know if you try to separate the feature files for this changing rate that you have or something like that, I don't know.
Okay, so for the maintenance part, like for writing user stories and feature files, it's always that since we are an agile team, we sort of write it together in the sense it's like one developer, our product owner, and also a person from like the quality assurance team, and there's also a compliance and validation officer there. So basically, it's just that they need to understand what we are testing for. And for the user story aspect of it, it is, so the requirements are defined by all of us together sitting there. But the user story aspect of it, we are sort of responsible for maintaining it ourselves. So like as soon as we know that the requirements have been written, we go and create a user story in our ADO, and then we sort of link it to like having this acceptance criteria, and it's completed when your test is executed. And to the second part, yes, that was only for illustration purposes. In our validation compliance processes, we also have certain manual steps that differ from BDD scenarios. So in case it's about going into something and logging in and everything, we also use a combination of just like having like a screen recording of doing that. So it's a combination of both.
More questions? Thank you.
Thank you so much. Thank you.